This is part 4 of our lesson on rational exponents. So this last question says simplify as fully as possible. And there are 3 different questions that involve rational exponents, but they also involve exponent laws. So when I'm doing a question, I always try to use my exponent laws for multiplication, division, or power of a power before I try to do a root or before I try to make a negative exponent a fraction. So my first question here says 81 x to the power of 8, y to the power of 20 in a bracket to the power of 5 over 4. So before I try to write that as a root or do anything like that, I would try to use my exponent laws first. So I notice I have a term with multiple variables, and then it has another exponent on top of it. So I would start by trying to use my exponent law for power on a power. When we have an exponent and another exponent on top of that, we multiply the powers together. So when I have 81 x to the 8, y to the 20 to the power of 5 over 4, that power of 5 over 4 belongs to the y, the x, and the 81. They all own that exponent of 5 over 4. So we're going to have 81 to the power of 5 over 4. We're going to have x to the 8 to the power of 5 over 4. And we're going to have y to the 20 to the 5 over 4. And then I'm going to try to use my exponent law that says that when I have a power on a power, we multiply those exponents together. Now, that's not the case with the 81, so we're going to leave that for a moment. It only has the one exponent. But this one has 2 exponents. So I'm going to multiply 8 times 5 divided by 4. So 8 times 5 divided by 4 is 10. So this is going to be x to the power of 10. And then 20 times 5 divided by 4 is 25. So I notice that 2 of the exponents now aren't fractions at all, and it's just the one on the 81 that is still a fractional exponent. So I'm going to leave the x to the 10 and the y to the 25 alone, but the 81 to the power of 5 over 4, I am going to try to write that as a root or a radical and then see if I can evaluate. So this is going to be the number on the bottom, the 4, becomes a root. So this is the 4th root of 81 to the power of 5 times x to the 10, y to the 25. And then I'm going to use my calculator to see if I can calculate that. So on this calculator, I'm going to do the number first. So 81 to the power of 5, big number. And then second, my exponent button, 4 equals. And I get 243. Now just to check on the other calculator, this one I put the number in first, so I would put the 4 in first, and then second my exponent button, and then 81 to the power of 5, and I get 243. So this is 243 x to the 10, y to the 25. Right, we're going to try part B. So in part B, my question says 686 x to the power of 19 divided by 2x, and then all to the power of 7 over 3. So when I'm trying to do one of these questions, I always try to follow order of operations, or BEDMAS, meaning I should start with brackets. Is there anything to do inside of that bracket? Yes, there is division. So I'm going to start with the division inside of the bracket, and then I will deal with the exponent on the outside. So inside the bracket, we are dividing. We do have division rules for exponents. We said if you're dividing two powers with the same base, you can subtract their exponents. Now I noticed that this has two parts. It has a number, a coefficient, and it has a variable. So the variable on the top matches the variable on the bottom, so I can use exponent laws for that. But the numbers are not the same base, so I can't use exponent laws for that. It doesn't mean I can't do anything, it just means I'm not using an exponent law. What I am going to do is 686 divided by 2, which is 343. And then x to the 19 divided by x. That x has a secret exponent of 1. And we said when you're dividing, you subtract your exponents. So 19 take away 1 would give me x to the power of 18. And then that is in a bracket to the power of 7 over 3. So now that I've simplified my bracket, I'm going to try to deal with the exponent. That exponent belongs to the x and the 343. So this is the same thing as 343 to the power of 7 over 3 and x to the 18 to the power of 7 over 3. Now 343 to the power of 7 over 3, that just has one exponent, so I don't need to do anything else with that yet. But the x to the 18 to the 7 over 3, if I look at my little sheet of exponent laws, anytime you have a power on a power, so one base, two exponents, we multiply those exponents together. So I would do 18 times 7 divided by 3 on my calculator, and I get 42. So this is x to the power of 42. Now I could leave my answer like that, but I don't really like having that fractional exponent on the 343. That 3 in the exponent becomes a third root. So this is the third root of 343 to the power of 7, and then times x to the 42. I'm going to use my calculator to work that out. So on this particular calculator, I should do it on this side, I do 343 first to the power of 7. That gives me a very, very large number. And then I do second, my exponent button, and 3 to do the cube root. And I get 823,543. And then x to the 42. If I try the other calculator, displays on the other side, I'm going to do the 3 first. So I do 3, second, exponent, 343 to the power of 7. And I get 823,543. All right, we have one last question. And this one has a number of exponent laws for us to use. So I have a to the 75, b to the 23, times a to the 7, b to the 13, divided by ab to the 3 all squared. And then that whole thing is in a bracket to the power of 3 over 10. So when I'm doing a question, I always try to follow order of operations, meaning if I have a bracket, I start with that. So I do have a bracket here. So I'm going to start by trying to simplify what is inside the bracket. Inside the bracket, I have multiplication, and I have division, and I have a power on what's in the denominator. So I would start with the exponent, but because the numerator and denominator are kind of separate at this point, I can do the multiplication in the numerator, and I can do the power in the denominator in the same step, and it won't really affect each other. So on the top, multiplication, when I multiply two things with the same base, I add their exponents. So I'm going to do the a with the a, the b with the b, right? So I have a to the 75, a to the 7, 75 plus 7 is 82. So I have a to the 82. And then b to the 23, b to the 13, I add their exponents to get b to the 36. That's in the numerator. In the denominator, the a and the b both get the square. So the a gets the square and the b gets the square. So I have a squared and then I get b cubed squared. They both get the square. Then this whole thing is still in a bracket to the power of 3 over 10. I'm not done with the denominator yet. I still have to figure out what's happening with that b. So I'm going to copy down the numerator, a to the 82 over b, a to the 82, b to the 36. In the denominator, the a squared is fine. The b to the 3 to the 2, anytime you have one base with two powers, we multiply those exponents together. So 3 times 2 is 6. And that is in a bracket to the power of 3 over 10. All right, so we simplified the numerator, we simplified the denominator. Now I just need to divide. When we divide two things with the same base, we can subtract their exponents. So I would do a's together and b's together. So a to the 82 divided by a to the 2, I would subtract 82, take away 2 to get a to the power of 80. B to the 36 divided by b to the 6, I would do 30 take away 6, which is, 36 take away 6, which is 30. And then that is still, to the power of 3 over 10. It's the never-ending question here. Okay, we're not done yet. I've finished simplifying the bracket. Now I need to deal with the power. So this power of 3 over 10 belongs to the a and the b. So this is a to the 80 to the power of 3 over 10. And b to the 30 to the power of 3 over 10. Okay, 80 times 3 divided by 10 is 24. So this is a to the 24. And then 30 times 3 divided by 10 is 9. So b to the 9. So sorry, I didn't explain why I did that. Anytime you have one base with two powers on it, we multiply those powers together. So that's why I multiplied these. So I did 80 times 3 divided by 10, and then 30 times 3 divided by 10. So final answer doesn't have any negative exponents. I've got one term with a, one term with b. We are done. Thank goodness. All right, so your homework is to work on the rational exponents practice on the bottom part of this sheet, and I will see you tomorrow.